Hi everyone, welcome to Pint of Science 21, the Body and Mind event. And unfortunately we can't be in the pub to have this event, but sure look, we'll make do with the virtual. So just to give you a bit of an introduction about me, so I'm a second year postgraduate researcher working with the Ocular Therapeutics Research Group in WIT under the principal supervision of Dr. Lawrence Fitzhenry. I'm also co-funded by a company in New Jersey called Ocumedic. So to explain my research, so my nearest and dearest like to refer to me as a bit of a mad scientist, okay? Because I always tell them, and forgive me for sounding like every face cream ad on the television at the minute, that I'm going to reverse the aging process, starting with our eyes. Intrigued? I really hope so. Okay, so to explain this, I want you to picture a house where every room in that house is lit up. Every light in that house is powered by an energy source. So now as time goes on, if you can picture things like phone chargers and kettles being plugged around into all the sockets in this house. So they're going to start draining that energy source. The lights in the house aren't getting the sufficient energy that they need to stay on, and they begin to shut off. So if this energy starts to be constantly drained, and if this is allowed to continue, pretty soon all the lights will be shut off, leaving us in complete darkness. So this is exactly what happens in our eyes as we age. So if you can think of it, that the lights represent our cells in our eyes. The energy source represents an essential chemical that is naturally produced by our bodies. So this chemical is used in the conversion of food that we eat into cellular energy in a process known as cellular respiration. And this helps to maintain a normal, healthy cellular environment. But as we age, the processes that consume this chemical start to outweigh the processes that make this chemical. So there's an imbalance. So our cellular energy that would normally be at such a high level is now starting to decline. Okay, so this leads to our ocular cells starting to shut down and become dysfunctional. And if this dysfunction keeps happening, this leads to ocular disease. So if this continues, as we age, our ocular cells become so irreversibly damaged that it leads to visual impairment, and in more extreme cases, complete loss of vision. So, i.e., all of our lights have gone out. So what I plan to do is to supplement this chemical supplement the concentration of this chemical back into the eye before that imbalance actually happens. So just to take a step back for a minute. So I'm looking at putting this chemical into the eye, but there are a number of ways that we can do this. So if you think about it, things like eye drops, ointments and gels are normally used to treat diseases that affect the front of the eye, whereas the back of the eye diseases are normally treated with things like intravitreal injections and implants, okay? Well, if you're anything like me, and my mom and dad in the audience will agree with me here that injections are the last thing you want to be getting into the back of your eye. So I thought maybe we should look at something that's, minimally invasive, but gets the job done. So I started to look at nanoparticles. So if you can picture the eye is a really, really protected organ, okay? So it has a lot of anatomical barriers in there that prevent the migration of things like dirt, bacterial cells, foreign debris through the eye, okay? So it wants to protect itself. But the problem with that is that if you're trying to get a drug molecule in there, it'll block it in the same way as it does a bacterial cell or dirt. But due to the size of nanoparticles, they can actually bypass these barriers and deliver that drug to where it needs to be at a high concentration. So you're getting more of an effect there. So just for reference, I'm just going to share my screen here for a second. And just give me a thumbs up if you can see this okay. So this is a reference of how big a nanoparticle actually is. So if you were to look at this, that in the top left corner, if a nanoparticle was the same size as an IRFU rugby ball, that would mean a cupcake would be the same size as the whole of Italy. And then this cute little rabbit in the corner would be the same size as the entire globe. Okay, so if you can gather from this, nanoparticles, extremely small. Okay, so the nanoparticles that I'm going to make are based on a positive charge and a negative charge coming together to form a neutral particle. So it's the age-old theory of opposites attract. Okay, so if you add one of these materials in excess of the other, you can actually create stable particles because the excess charge on the surface of these particles are going to repel each other. So they're able to stay stable in solution. Okay, so you have the opposites attract to form them, but like repels like for stability. So I'm a firm believer in natural medicine. Okay, so I chose these materials for my nanoparticles based on